Hello everyone, welcome to part 2 of covalent compounds. We're going to be looking at naming compounds. Alright, so we need a common language when we talk about compounds and molecules. We speak chemistrian, right? We need to learn how to speak chemistry so we can have a common language and understand each other. And so there are some rules for naming compounds. So the covalent compound rules are slightly different than ionic compounds because ionic compounds only can form in very specific ways, right? Ions take specific charges and they form in proportions that leave neutral. Well, covalent compounds are always neutral as well, but there's a variety of combinations. Like even nitrogen and oxygen can form in multiple ways. So we introduce a new element to the naming, which are prefixes. So binary compounds, what we mean by that are just two elements. Binary compounds are named by assigning the element name to the first atom, so just the normal name of the element, followed by the element name of the second atom, and changing the ending to "ide," so the same as we did with ions. And then, here's the difference, prefixes are placed before the element names to signify the number of that atom type. And here are the Greek prefixes. So mono, di, tri, tetra, penta, and hexa, and it continues on past that, but up to 6 is good enough for now. So one thing to note, right, number one, if there's only one atom, it's called mono unless it's the first element, and then we just ignore it, right? So you might have a CO detector in your house, right? CO is carbon and oxygen, and we call that what? What is your detector? It's carbon monoxide, right? It's not monocarbon monoxide, but the mono does go on the second element, and then it ends in "ide." It's assumed if there's no prefix on the first one, then it must be mono, right? CO2 is another one. It's very well known, well talked about. So it's carbon, and then O2 makes dioxide, carbon dioxide. Okay. Here's a few more examples. NO. Here, NO is nitrogen monoxide, right? So again, the nitrogen on the front does not have the prefix, but the second element, monoxide, does. But if it's N2O, now we do need to include the prefix on the first one. So it's dinitrogen monoxide. 2 N's, 1 O. Here's another example, P2O5. So the P2 is phosphorus, and there's 2, so it's diphosphorus. And O5, so pentaoxide or pentoxide. Notice when the two vowels were to make like AO, like pentaoxide or monoxide, the first vowel is dropped just for pronouncing. So the binary compound of oxygen above, monoxide, pentoxide, right? By the way, you do not need to remember these. Like a lot of these kinds of things, you will probably memorize them just from usage, but you do not need to. So if you need to look it up for now, definitely do so. So here's some practice for you. Given the molecular formula, write the name. Given the name, write the molecular formula. So I'll let you pause and do that on your own. Okay, welcome back. So the first one is iodine trichloride, right? The next one, N2O2, dinitrogen dioxide. Next one, SiCl4, silicon tetrachloride. PO5, phosphorus pentoxide. All right, hopefully that went well. Let's go to the names and give the molecular formula. Dinitrogen tetroxide. So it's nitrogen. The di tells us it's 2, and oxide, tetra, tells us 4. Phosphorus pentabromide, PBr5. Similar to this one, right? Phosphorus pentoxide, phosphorus pentabromide. Nitrogen monoxide. Oh, we already had that one. And no. Last one, sulfur trioxide, SO3. Okay, so again, hopefully that went well. There's lots of practice for this. Once you get it, it generally goes pretty smoothly. Notice all of them are neutral, right? SO3 with a minus charge is called sulfite. That's a polyatomic ion. That's different than sulfur trioxide. Okay, so notice the difference between ionic naming and covalent naming, because a lot of people get mixed up, and once they learn mono, di, tri, and so on, want to start using it all the time. And remember, we don't use those for ionic compounds. So this exercise here is pretty good. It just says name these, right? And so you have to figure out if it's ionic or covalent and then give it a name. So first say or write is ionic or covalent and then give the name. So try that on your own. So pause it and then come back. Okay, welcome back. So let's look at the answers, right? A, well, first off, how do you know? Well, aluminum is a metal and a nonmetal is chlorine, right? So a metal and a nonmetal means ionic. They're going to form ions. And so the name is just aluminum chloride. We don't need trichloride or anything like that. If it's ionic, there's only one way we can put aluminum and chlorine together. They're transferring electrons. So there we go. Okay, CS2, carbon and sulfur are both nonmetals, so this would be a covalent molecule. And then the name would be carbon disulfide. Okay, FeO, a metal and a nonmetal, so that is ionic. And this one's a little bit tricky if you remember. It's iron 2 oxide. So when there are multiple ways that a compound can form between two atoms, such as this one, we use the Roman numerals to indicate the charge. We don't use the prefixes, right? So iron 2 oxide would be C, and then D, nonmetal and a nonmetal. So covalent, and we may have encountered this one earlier, I don't remember, but N2O4 would be dinitrogen tetroxide. It's not tetraoxide, it's tetroxide. Okay, So good practice to be able to identify and differentiate ionic and covalent, and then be able to name them appropriately and correctly based on that. Speaking of correctly, here's a multiple choice question. Select the incorrect name, and I'll add in correct it. Pause and figure out which one of these is wrong and how so. A, carbon monoxide is correct, right? CO. I'm going to skip one and go to C. N2O4 is dinitrogen tetroxide. Phosphorus tribromide is correct. Carbon tetrachloride is correct. And sulfur dioxide is wrong. That would be SO2, or SO3 would be sulfur trioxide. Okay, I have one more for you. Which compound is ionic? So go ahead and pause this and answer for yourself. Okay, welcome back. So they are all an atom and oxygen, and that's it. Right, but carbon is a nonmetal, nitrogen is a nonmetal, calcium is a metal, sulfur is a nonmetal, and fluorine is a nonmetal. And so calcium oxide is ionic, and the others are all covalent. Okay, folks, that's actually all of section 3. So we're going to finish this up with just 2 parts today, and make sure you get plenty of practice here. The key points are a covalent bond is sharing electrons, and we need to learn how to name binary covalent compounds. All right, so we have one section left, which will be shapes of these molecules.